Okay, and we're back. Here's the deal. We are going to do 4 law of cosine problems that are going to be very similar to the things that we've already done and very similar to the things you're going to see on the worksheet that you're getting ready to work on. So where I'm going to introduce a problem to you, we're going to pause the video, have everybody try it. Probably take you about 3, maybe 4 minutes. Unpause the video, and then I'm going to work through it, make sure you get exactly what I have. Okay, so on this very first problem, what I'm looking for you to do is you can see that we have side, angle, side. So you're going to use the law of cosines to find x, and then once you have x, you can use the law of sines to find a and b. So there you have it. We can pause the video right here and find a, x, and b. All right. Okay, let's see how you did. This is a pretty straightforward problem. Hopefully at this point, law of cosines has become really simple to you. I'm going to scroll up even though we're going to lose a little bit of it, but I remember what the information is. What we got? We got a 15.3 side. We've got a side that's 14.9, and the angle in between them is 31 degrees. Okay, so we know that it goes a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. And so in that case, that would mean that x squared is equal to 15.3 squared plus 14.9 squared minus 2 times 15.3 times 14.9 times the cosine of 31 degrees. And that's when I plug it all into the calculator. I'm going to say 15.3 squared plus 14.9 squared minus 2 times 15.3 times 14.9. And you might go, why the decimals? Well, get over it. Using a calculator anyway. Doesn't really matter. And I get 65.28314. So you go x squared is equal to 65.28314, something. And so then I square root that. And you can do that by hitting second and then the x squared button and then second and then the negative symbol. And it'll put ANS, the previous answer, in there. And I get 8.09 or 8.0797. So it'd be 8.08 if I went to 2 decimal places. And so that's the length of this side over here. We're saying that this would be about 8.08. All right, so now what we want to do is we're going to use the law of sines to find the measure of these other 2 angles. Okay, and so I'm going to start with, we'll start with angle A. And so I know that the sine of 31 degrees is to 8.08 in the same way that the sine of whatever angle A is to 14.9. And I cross multiply, and I'm going to end up with, I'll skip a couple of the steps because I'm sure that you guys can do it, but I'll know I'll have 8.08 times the sine of A is equal to 14.9 times the sine of 31. I got to divide both sides by 8.8, and I'm going to end up with A is equal to the inverse sine of 14.9 over sine of 31, or sorry, times sine of 31, all over 8.08. So then I put that in my calculator. Inverse sine, 14.9 times the sine of 31, close the sine parentheses, divided by 8.08, close the parentheses, hit enter, and I get 71.76 degrees. So you go A is about 72 degrees. Okay, so if that's the case, if A is about 72 degrees, and we were given a 31 degree angle, that gives us 103. So that would leave, what, 77 degrees for this last one right here. Okay, now a quick check to make sure that these answers make sense. Okay, we look at the biggest side, which is this, that's not what I want to do. The biggest side is this 15.3, is opposite the biggest angle. The smallest side, which would be this 8.08, is opposite the smallest angle, and therefore the medium-sized side is opposite the medium-sized angle. So everything seems to make sense, and those answers are correct. All right, now let's try a situation where instead of you looking for a side, I want where you're looking for an angle, because you're given all 3 sides. All right, so in this one, you're given the side 11.6, 15.2, and 6.8. And your job is to not only find this x, or the measure of angle x, but also to find A and then to find B, which is going to be the measure of those angles right there. Okay, so again, you can use the law of cosines to figure out what x is, and then it's usually easiest to use the law of sine to figure out A and B. So we'll pause the video here, pick up in about 3, 4, maybe 5 minutes, and I'll work through it. All right, let's see what you got. This is a crazy problem. I'm really curious if, as you guys were solving it, if people got different answers. Because the wild thing is you can do all the math right and get the wrong answer with this problem. And it's part of because of that ambiguous situation that we talked about before. Remember when we talked before, we said sometimes we have these triangles that we know an angle and then two different sides. Hang on. And it could look like this, or it could look like this. We're not sure. It's one of those two situations. And so either we have a triangle that looks like this, or we have a triangle that looks like this. Because this side right here is the same length, whether it's right there or right here, and we're not sure about this angle. And so we had situations like that where we weren't sure which way it was supposed to go, all right? And that's what can happen with this one, in a sense. And so there's actually a correct way of doing this, and there's an incorrect way of doing all the math right and still getting the wrong answer. You might not know anything about what I'm talking about, but I'll show you in just a second. Okay, so first of all, we got to figure out x. And that one's easy. We know that the cosine of that angle is always equal to the two sides that create that angle squared, added up, minus the side opposite of it squared, divided by 2 times the first two sides that we were talking about. Okay, and so then I know that x is equal to the inverse cosine of all of that. Now remember, every time you type in inverse cosine, it opens up one set of parentheses. You need to open up another and put that whole top part in it. 11.6 squared plus 15.2 squared minus 6.8 squared, close the parenthesis, divided by, open the parenthesis, 2 times 11.6 times 15.2, close the parentheses, close all of the parentheses. And that's what you should be putting in the calculator. So inverse cosine, 11.6 squared plus 15.2 squared minus 6.8 squared, close the parentheses. I don't think I ever opened up a new set of parentheses. Let me go back and make sure. Yeah, remember always at the beginning, you got to open up a new set of parentheses. I got those two there. 11 squared plus 15.2 squared minus 6.8 squared, close the parenthesis, divided by, open a new set. 2 times 11.6 times 15.2. Close parentheses, close the whole thing. Hit enter. And I get 25.09. Now remember, this is an angle. So we're going to round to the nearest degree and say, man, this is about 25 degrees. So we get in this picture that this one right here is 25 degrees. Now, let's go ahead and figure out angle A, okay? And so then how I do this is I'm going to use the law of sines. I know that the 25 is opposite 6.8. So I can say that the sine of 25 degrees is to 6.8 in the same way that the sine of what A is 15.2. Is to 15.2. Okay, I'm going to cross multiply, and I get that 6.8 times the sine of angle A is equal to 15.2 times the sine of 25, not 29. Okay, divide both sides by 6.8, and I end up with A is equal to the inverse sine of 15.2 times the sine of 25 degrees all over 6.8, close parentheses. So I'm going to put that in. Inverse sine, 15.2 times sine of 25, close the sine parentheses, divided by 6.8, close all parentheses. Hit enter, and I get about 71. So A is about 71 degrees, okay? So I say this is 71 degrees. So I got 25 plus 71 gives me 96. And so that would leave 84 degrees for B. Okay, now I'm really curious. I really wish I was there to know, did you guys get these answers or not? Because if you got these answers, you're wrong. Okay, these cannot be the right answers. And everyone in here should know that. The biggest side is right here, 15.2. It's opposite of 71 degrees, which is not the biggest angle. The biggest angle is opposite of 11.6, which is not the biggest side. And so there's something clearly wrong. This triangle could not exist in this format. You could have a triangle with 11.6, 6.8, 15.2, but it will not have these three angles inside it. But yet all of our math is right. So here's the correct order, okay? We're gonna go back. when you're doing this, and let's say you just started this problem, there we go, and you found out that x was 25. Your basic rule here on out is to then look for the angle opposite the next smallest side. Don't go to the biggest side, like this 15.2, but go to the next smallest side. If you already did one that was like the medium size, then go to the very smallest. But in this case, we already did the smallest side, 6.8, because that was opposite of the x. So now let's go to the 11.6, and let's see how this works out. So now instead of doing this, now I start with the same thing, but I'm going to get rid of all this. Okay, let's see here. There we go. Okay, so now I'm going to start with sine of 25 is to 6.8, but this time instead of saying like the sine of A is to 15.2, I'm going to say as the sine of B is to what's opposite of B, 11.6. Now cross multiply with that. 6.8 times the sine of B is equal to 11.6 times the sine of 25. I mean, you guys know where this is going, so I'm going to jump ahead and say B is equal to the inverse sine of 11.6 times the sine of 25 all over 6.8. And then plug that in my calculator. Inverse sine, 11.6 times sine of 25, close the sine parentheses, divided by 6.8, close parentheses, hit enter, and I get 46 degrees. So I get that B is about 46 degrees. Now let's go back up to our picture. Now if this was 46 degrees, and that's 25, 25 and 46 would give me 71, which would make this one 109. Now these are completely different numbers than what I just had, but these numbers make sense. 25, which is the smallest angle, is opposite the smallest side. 46, which is the next smallest angle, is opposite the next smallest side. And 109, which is the largest angle, is opposite the largest side. Now, that's how you should do this. If you've done the smallest, move on to the next smallest. If you haven't done the smallest, then do the smallest as you're using the law of sines. Now, just a little side note, I'm not sure if anybody notices, but I'm not sure if you remember what angle we did get for A. And it was 71 degrees. And if you notice, what's the connection between 71 and 109? Well, they're supplementary. And so it's like that ambiguous case before where the calculator has a hard time figuring out which is which. So that's why it makes more sense to go with the smallest angle, okay? And go with the smallest side that you can. So that way the calculator can understand things and it'll do it right. All right, so these are the correct numbers right here. All right, next problem. Okay, next problem, here we go. The diagonals of a parallelogram are 56 and 34, and they intersect at 120 degrees. Find the length of the shorter side of the parallelogram. Okay, so here's our numbers, 56, 34, and 120 degrees. Now let's go back and remember, four-sided figures. We knew that the diagonals of a parallelogram always bisect each other. Now, they're not always perpendicular unless it's a rhombus or a kite, and a kite isn't a parallelogram. But if with just a regular parallelogram, they can intersect at any angle, and for these, they intersect at 120. So I want us to think about what this generally looks like. The diagonals are 56 and 34, okay? So let's say this side right here is 56 units long. And then we'll say, it's gotta be considerably shorter than that. We'll say that side's about 34. Okay, so this first one, we're saying is 56. This one we're saying is 34, okay? And I would say that this is somewhere around 120 degree angle, which would mean the angle next to it would have to be 60 degrees. Now, I'm not saying that I've drawn anything very good that's gonna even remotely look like a parallelogram, but we're gonna give it a try. Looks something like that. Oof, that last side was rough. There we go. Okay, now, we know that the diagonals of a parallelogram bisect each other. So if that whole thing is 34, then we know we've got 17 over here, 17 over here. If that whole thing is 56, we have 28 over here and 28 over here. Now, we're looking for, it said, the shorter side of the parallelogram. Well, that would be this side right here, okay? Which is actually gonna come from the 60 degree angle, not the 120. Clearly, the 120 degree angle is going to be opposite of the much longer side. So here's the hardest part about this, is actually going from all the words given to you to the situation that it creates. Some of you might have a little bit of problem with that, but we just got to go back to what we know. The diagonals of a parallelogram always bisect each other, okay? So that means we're going to take those numbers that they give us and cut them in half to create our triangles. And then we got to look and label this angle and realize what angle is going to be supplementary to it. Sometimes we might want the larger one and the side opposite of it, and sometimes we might want the smaller one, like in this case. So now let's take a look at how we're going to do this. So I want to find the length of this side right here. So I'm going to call that x. Well, this is a perfect law of sine or law of cosine situation because I've got, let's see here, I've got side, angle, side. Okay, so this is a perfect law of cosine situation where I could say x squared is equal to 28 squared plus, not 34, started to write the wrong number, 17 squared minus 2 times 28 times 17 times the cosine of 60 degrees. At this point, I plug it all into a calculator. 28 squared plus 17 squared minus 2 times 28 times 17 times the cosine of 60 degrees, close parentheses. Hit enter, and I get 597. Isn't that funny? It came out to be a nice, perfectly clean number. X squared is equal to 597. That happens once in a while because in this case, the cosine of 60 is exactly 1/2. It's not some crazy ugly decimal. Cosine of 60 degrees happens to be 1/2. So let this come out to be a clean number. So therefore, x is approximately, let's take the square root, about 24.4, okay? And so with this, we know that x is going to be about 24.43. All right, and that gives us the length of the shorter side. Okay, now, I know we were going to have you work these problems, but I figured that one might be a little bit too much right out of the gate. So what I'm going to do is now I'm going to go through and change some numbers, and I want you to try the exact same problem. So we're going to take out the 56, the 34, and the 120, and we're going to change this up. We're going to say that the diagonals this time, one of them is 82 inches long, feet long, meters long, centimeters long, and the other one is, let's make it 48. And the angle between them is 135 degrees. And this time, go ahead, find the shorter side. So it's going to help if you draw a picture to start, so that way you can kind of figure out where everything goes and find the length of the shorter side. So we can go ahead and pause the video. I know this one might take a few minutes longer, but I don't think it'll be that much longer. So pause it now and we'll take a look at it in a second. Okay, hopefully you got this. Let's see here. I don't have to erase everything I've got, but I'm going to erase a lot of what I've got. Let's see here. Clearly all those numbers are wrong. And we'll go with about that. Okay. So in my situation, if my longer diagonal is 82, that means there'd be 41 of it over here and 41 of it over here. My shorter diagonal is 48. That means 24 of it would be over here and 24 of it would be over here. My bigger obtuse angle is 135. So then supplementary to that would be 45 degrees. I'm looking for the shorter side, which is right here. And I've got this perfect side angle side situation. So figuring this out should be relatively simple. I'm going to erase all that. And for good measure, scoot this over. There we go. Okay, so now we say, I know that x squared is equal to 24 squared plus 41 squared minus 2 times 24 times 41 times the cosine of 45 degrees. So you get x squared is equal to, and I'm going to put that in my calculator, 24 squared plus 41 squared minus 2 times 24 times 41 times the cosine of 45 degrees. And I hit enter. And I get a pretty ugly number, 865.413 something, something, something. So therefore, x is about, I'm going to square root that, I get about 29.417, so that becomes about 29.42. Okay? And that is the length of the shorter side of that parallelogram. I could also easily find the length of the longer side. I would use almost everything the exact same, except I'd be changing the angle right here. And it would give me a completely different answer. All right, so hopefully this is what you got, 29.42. All right, so now last problem. Here is the problem. Two turtles crawl away from the same spot. One is crawling at 18 feet per minute, while the other one's crawling at 22 feet per minute. If the angle between their courses, or direction of travel, is 123 degrees, how far apart are those turtles after 2 minutes? Now, hopefully you understand what in the world this is saying. Okay, I'll give you a bird's eye view real quick. All right, so we've got one turtle, see its shell, is going that way, okay? And it came from maybe right here. And this turtle is moving at, what was one of them, 22 feet per minute. And the other one is going about that way. Again, there's its shell. And this one's going at 18 feet per minute. And the angle between their courses is 123 degrees, all right? And so our goal is to find out how long is it, there we go. How long is, or what is the length of the distance between them after 2 minutes? Now realize that they do 22 feet per minute or 18 feet per minute. So now we got to think about per 2 minutes. So really what that does is it just doubles the length of those two sides. So instead of 22, this one would become 44. And instead of 18, this one would be 36 because it's after 2 minutes. So we can take out the per minute and just say it's that many feet. All right, this is a perfect side situation. Very easy problem to set up. You're gonna say x, or that distance squared, is equal to 44 squared plus 36 squared minus 2 times 44 times 36 times the cosine of 123. So therefore x squared is, plug it into my calculator, 44 squared plus 36 squared minus 2 times 44 times 36 times the cosine of 123. And I get about 4,957. 4,957.416, so on. So therefore x is about, and I'm going to take the square root of that answer, and I get about 70.40. It'd be 41 when I round it up. Okay? And so what is this number right here? That means that after 2 minutes, the turtles are 70.41 feet apart from each other. Okay? And you should be able to do that. So, same thing. We're gonna try the same problem, but I'm gonna switch up the numbers here. Let's see, these other turtles in this new problem are gonna be really fast. Okay, this one's crawling at, oh my goodness, 28 feet per minute, and the other one's doing 32 feet per minute. I wanna know how far they make it after 3 minutes, and the angle between their direction of travel is 137 degrees. Okay, so here's the numbers. 28 feet per minute, 32 feet per minute. We wanna know after 3 minutes, and there's 137 degrees in between their direction of travel. All right, we're gonna pause the video right here, give you guys about 3, 4, maybe 5 minutes, try this problem, and then I'll work through it. All right, hopefully you see that this is just, I mean, there's nothing hard about this. There's nothing at all hard. Let's see here. I mean, this is a really simple situation. Okay, so for right here, I'm just gonna take this stuff out and say, okay, we're still looking at a relatively similar situation. The numbers for this one, the angle is 137 degrees. Okay, the first one's traveling at 28 feet per minute. 28 feet per minute times 3 minutes would be 84 feet, okay, that it's traveled already. This other one is going 32 feet per minute. After 3 minutes, 3 times 32 would be 96 feet. And there's our situation. We're looking for this distance right here. So the distance squared is equal to 84 squared plus 96 squared minus 2 times 84 times 96 times the cosine of 137. Plug that whole thing into my calculator. 84 squared plus 96 squared minus 2 times 84 times 96 times the cosine of 137. Close parentheses, enter. I get that it's about 28,067.27, So therefore the distance is about, and I'm going to square root that, distance is about 167.53. 167.53 53. And what does that mean? That means that the two turtles are 167.53 feet apart from each other after about 3 minutes. All right, hopefully you got the same answers I got. We're gonna do a worksheet right now that has these problems and this type of problem. And so you should be excellent at it. If you need to review any part of this video, please do so. See you guys later. Good luck.